I will speak in Vietnamese actually, because most of you are Vietnamese. Just my friend here is the only one who doesn't speak Vietnamese, so I can explain to him later on. So, chào mừng tất cả mọi người đến với hội thảo Tetcon năm 2013. Đây là năm thứ 2 và đúng là năm nay thì hy vọng là cái việc tổ chức nó tốt hơn năm ngoái một chút. Cũng còn rất là nhiều trục trặc nhưng mà tôi nghĩ là nó tốt hơn. Năm nay thì mình có được khoảng gần 400 người đăng ký, và nhưng mà số lượng khách ở đây thì mình khoảng chắc là khoảng 200 người. Thì chỗ ngồi của mình nó sẽ hơi bị thiếu, tại vì ghế ngồi mà như vậy là chỉ có khoảng 170 ghế thôi, và ngoài sau phía sau là cũng còn khoảng 40 ghế nữa. Thì vui lòng mọi người nếu mà ở giữa mà cũng còn chỗ trống thì mình ngồi xếp vô trong để chừa chỗ bên ngoài cho các những người đến sau. Rồi thì tôi cũng không có nói gì hơn, chỉ là chúng ta sẽ bắt đầu ngay bây giờ. Thì nếu mà trong quá trình mà diễn giả mà họ nói chuyện á, mà mọi người có câu hỏi gì đó thì như anh Đạt đã nói rồi á, thì mọi người đi xuống và có các bạn thành viên đứng ở hai góc thì sẽ nhận những câu hỏi đó và gửi lên trên đây. Ngoài chính cái bài nói chuyện chính thức đó, thì buổi cuối của hội thảo mình sẽ có khoảng 1 tiếng để về mình sẽ thảo luận, có một cái buổi nói chuyện với lại các diễn giả. Trong đó mình có thể là đặt thêm các câu hỏi mà trong thời gian chính thức mình không có đặt kịp, do mình chỉ có 45 phút thôi. Cái thứ hai nữa là mình sẽ tập trung những câu hỏi xoay quanh cái chủ đề đó là làm thế nào để mình có thể trở thành một cái người làm việc trong cái ngành này, và hoặc là mình có thể bắt đầu nghiên cứu trong cái lĩnh vực này. Thì xin cảm ơn và chào mừng mọi người đến với hội thảo hôm nay.
Trên sự đề nói tiếng Anh. Without any further delay, the very first speech about Tyranny of small decisions by Eduardo Valle.
Hello. Hello. My name is Eduardo Vela. I work in Google, and I come to talk about mostly about the problems that have resulted by the current form that we do the web security in general in the industry. It's called Tyranny of small decisions, mostly because of this quote that I found when I was looking for something else, which is a situation where a series of small individually rational decisions can negatively change the concept of other decisions. That means that if a lot of small good decisions are made without having a big picture in mind, it could end up having a bad outcome, even if all the small decisions that were made were good. Oops, this is weird. So, to talk about myself, my name is Eduardo Vela. My nickname is Darket, if you follow me on Twitter. I do coding, I do research and stuff, and the type of security I like to do is to find bugs that are very hard to fix, because they live longer and they cannot fix them. I work as a tech lead in Google's product security response team, and yeah, that's all about me. Oops, there we go. So, to give a little story about where this presentation comes from is when I was studying, I used to report vulnerabilities to a lot of companies, mostly like Google, PayPal, Microsoft, and stuff. And I used to make fun of the vendors for not getting security, right? It's like, how come a teenager can find vulnerabilities in these websites or in this software developed by professionals? Then I went to work for Alibaba and for Google and stuff, and I started realizing that it's really frustrating because while there are some people that know how to do stuff, they have to take care about other things, and it's at that point in time I was blaming the developers, right? It's like, oh, it's all their fault. But in real life, what happens is like it's very hard to do security right, especially web security, and well, that's what this presentation is about kind of vindicating developers, not because it's their fault, but because it's actually someone else's fault. So when you ask a developer what an average developer, even professional developers, know about web security, is whatever they get security warnings for. So if they go to a website and the website has a mixed content warning, they will think that there's a security problem. But in reality, the security problems that really exist, the important ones are the ones that the browser will not go out and tell you, like, there's a bug here, but the ones that someone else has to go and find them. So, when in Google, when we were trying to come up with what a web developer will have to know about security, we realized that it's not only the features that they want to implement, but how all the other features that the browser and the web server and everything supports mix with each other. We started with the W3C standard, and then we realized that there are like 227 pages just for this one page that leads to other 78 documents that are more or less the same size. And the worst case scenario is that that's only the expected behavior, and in reality, a lot of implementations actually differ from it and are expected to differ from it. Okay, there we go. Yeah, so that's more or less the problem. The reason that you have to know how every feature interacts against other feature is because you might not be intending something to happen in such a way, but actually it just happens because that's how the browser works. And you also need to guess how other services that live in the same origin interact with yours. Like, that's a problem as well, because you have to guess what everyone else wants to do or is attempting to do. And you need to understand what behaviors won't be changed later. This last part is actually kind of interesting. So you have to understand which behaviors will be modified or changed or adjusted by the standard bodies or the browsers later on in the browsers. And to answer this question, what features and behaviors you can use in general that you are guaranteed to never change are actually known. Like, there's a lot of things that you can like kind of assume that they are not going to change, and most likely they will never change. But there is nowhere that says this is going to change, this is not going to change, this is going to change. So to prevent this from being a big problem, the standard bodies try to prevent this from prevent new issues from being created. But I mean, they are not magicians. They sometimes have problems. In some cases, when there are discussions about these problems, there is something called the priority of constituencies, or whatever, which says that whenever a decision is going to be made, it has to be made taking users into considerations over authors, over implementers, over specifiers, over theoretical purity. And in some cases, well, security is complaints or concerns might be considered theoretical purity because there is no hard evidence that this is going to actually be a problem. So, I'm going to present two issues, two parts of web security. I only do two because otherwise this will take like a year. Authentications of users and authentication of requests. Authentication of users is usually done on cookies, basic, digest, or some of the other extensions authentication, on guessable one-time URLs, custom protocols, certificate-based authentication, usually for enterprise. And for web requests, usually done either abusing the same origin policy, using the referrer headers for some reason, and the CSR tokens and the origin header. So from this, the guessable one-time URLs are not really a good solution because they get stored in the history of the browser, and they might leak and stop using by mixed content problems or in several ways, like being used to have this problem that will leak all URLs via plain text. Then there is the custom protocols. I'm going not to talk about custom protocols because they are custom and I cannot discuss them. But anyway, so that's for authentication of users. For authentication of requests, using the same origin policy is actually not the right way because there is nothing in the same origin policy defined for authentication requests. The referrer header is the same. It has been defined in some RFCs, but it's actually not. It's not designed in a way to be a security feature, so there are several ways of disabling and stuff. And CSR tokens as the common way of using it, and I will explain why I crossed it out in another slide. So that leaves us with cookies, basic digest auth, certificates, and origin headers. The origin header is not supported by some browsers, so we cannot use it. Certificate-based authentication has a problem of key distribution, which is a big problem. So it's actually not useful for the average use case. It's only useful for things like enterprise or universities and stuff like that, where it's easy for you to go to each of your users and give them a certificate. Cookies is interesting. I will explain why not in this case, but cookies is actually okay. I just cross it so that I can discuss basic authentication. So basic authentication has a problem that it has to, the server and the client both have to know the secret. The client knowing the secret is okay, the password, but the server usually is not so much okay. The problem with that is that then the server has to store the password or has to be able to see it every single time in plain text. This authentication is very hard to do in distributed environments. That means having like a data center where your request can be served by one of hundreds or thousands of machines. It's a little hard to implement, and that's why a lot of web services don't do it. And also because you cannot customize the user experience of the user when they log in, and it's impossible to extend. Like if you want to use two-factor authentication or something like that, it's essentially impossible in HTTP authentication. So anyways, that leaves us with three options, right? HTTP cookies, which is not so bad. The certificate-based authentication, which is only possible, at least in the general case, for enterprise customers. However, there are certain extensions like certificate-bound, origin-bound certificates and client-user certificates that are generated on the fly and stuff like that. That actually makes sense. And for authentication of requests, only origin. So before I go to the next part of the presentation, I want to present a new term that is called the principle of least astonishment. Astonishment pretty much just means like users or developers should not be surprised by the introduction of how the system works. So they should match the developer's expectations, experience, and mental models. So these are examples of web security astonishment or traps. So the cookies have this contract, which is that only sites running on the same hostname and path visit the cookie and will have access to retrieve the value of such cookie. There are some extensions to this, which is the making the cookie secure or HTTP only, which have special meanings. But there's a gotcha. The same origin policy, which is not the same as the cookie security model, make no distinctions between paths. So actually you can read the cookies. This is a very well-known example. I'm just mentioning it for illustration purposes. Then, so this is a problem mostly because that means that if someone was depending on this behavior when they set the cookie, they are not going to be able to depend on this behavior anymore. Like there's a way to bypass such a thing, and that's something that could be considered like violating the principle of least astonishment. The same origin policy has this other contract, which is a script running on a given origin with a double scheme hostname port should only have access to data in the same origin. There are some extensions to this, like CORS and post message, that are very new, but in general, this is like the rule of the internet. Wow, something like that. There's a gotcha. There is the window.name property crosses origin boundaries. So that means that if there is a variable called name that is not trapped inside a closure, it's going to leak across origins. So for example, if you say that the name of the current user is Ty, then the next page that the user visits is going to know the name of the user and stuff like that. A page of any origin can navigate windows of other origins. So that means that you cannot trust the state of your application based on navigation of pages. Like an evil attacker can just simply tell the browser, please navigate this window 5 times in the past, and it will happily do so, or in the future. The code running on different ports have access to different cookies, even though they are different origins. This is also one example, but it's a way of communicating between two origins. The document cookie value set by one subdomain can affect the values of other subdomains, which is also a very well-known example. And anyways, so the consequences of all these problems. So these are like, I don't know, like 5 gotchas. And the consequence of so is that doing authentication via cookies and the same origin policy is a little tricky. Any site can delete any cookies that you set. So that means that if you set a cookie, if you set 3 cookies, an attacker can delete 2 of those cookies and you're only going to be left with 1 of them. Or an attacker can modify them and make them look different. So you have to keep the consistency of the cookies. You cannot trust them. You cannot say like this is a. You cannot say like I will authenticate the user A with cookie A, and then I'm going to authenticate in the other web page with this other cookie, because it actually might be different and it might be under control of attackers, even without problems like mixed content and stuff. The other problem is that even for cookies that are set under secure connections, they are overridable over unsecure connections. So, as I mentioned earlier, setting cookies to different paths doesn't help. And if you depend on more than one cookie, you have to keep the consistency between them in some way. So, for request authentication, which is cross-site request forgery, preventing cross-site request forgery, is slightly different. In user authentication, you want to know who is behind the computer. In request authentication, you want to know that a given request was initiated by your own application. So the only thing that you need for request authentication is to know who initiated the request. Sounds like an easy fix, and most people use referrer header, but actually you cannot use that because anyone can override it, and it's not something that you can trust across. Like if you're an HTTP site, an HTTPS site can generate a request that will generate an HTTPS referrer even though it's come from HTTP. So someone thought let's use crypto and use CSRF tokens, and now they have 2 problems. Because it's actually kind of hard to do CSRF tokens correctly. So what some people usually do is to just verify that the post token is the same as the value of a cookie. That has a problem that anyone can delete or override the cookies, as we mentioned earlier. So anyone can change the value of the cookie and then make any request they want succeed. So the way that attacker will work is the attacker replaces the cookie, performs a request, and they win the CSRF check. There's other cases like do an HMAC or some authenticated encryption of the user ID and the key, and a secret key. The problem with that is that if you don't expire the CSRF token, which is how most CSRF token works, if they don't expire the CSRF token, then it will be like a super cookie. It will be not tied to the session and so on and so on. So this problem comes because there is no other way of knowing where a request comes from. And it's something that it will be very easy to do from the browser. Like the browser always knows who initiates a request. And they created it, it's called the origin header. And now some browsers have it, but not all of them. So yeah, at least there's something that you can do from now on. But for previous, in the past, it was actually impossible. So, this is just one example of cookies versus same origin policy not being the same. But there are hundreds and hundreds of these. So this cookie security model differs from the same origin policy as I mentioned here. And the same origin policy is also not compatible with the cookie one. The flash security model differs from the same origin policy. and as well both different from Flash. The Java security model, the Silverlight security model, the Acrobat security model. The Java security model also differs from itself, like the way that they do Java signed applets is different from the way that they do cross-domain checks. The client certificate security model differs from the server certificate security model in when you get warnings and when the certificates are allowed to be shared. The mixed scripted security model, which is the dangerous one, the one that allows a page load over HTTP to execute things on HTTPS. No, a page load from a resource load from HTTP loading a page loaded from HTTPS is different from how it behaves for a mixed content. The same origin policy differs from the one for XML HTTP request. The same origin policy for HTTP URLs differs from the local file system URLs. So you might not have access to files that if you were running online, you will have access to otherwise. The behavior of the cookie jar differs on different process implementations. The behavior of URL parsing, of HTML parsing, and CSS features and recovery parsing change on each version and on each different process implementations. Behavioral security exceptions differs from process security implementations. That if they are going to trigger an exception that is catchable by the window, or they are going to throw an exception that is only visible in the console UI, how much information they leak at the moment that they throw such an exception, and so on and so on. And there are hundreds of more examples like this. However, this is a problem that we've noticed, like the web security community has noticed for a while. So most likely we're working with standard organizations to fix this problem, to fix this mess. However, we're not. We are, but not so much. So there is new problems. So there is, I'm going to present just one, but there's only also hundreds of these. The cross-origin resource sharing allows a website to disable same origin checks for a given HTTP request. It reduces the XML HTTP request API, and is used to be almost equivalent to same origin policy. It's not, but it almost was. So before course, a code like this will be actually kind of safe. So you have a HTTP request that does a get thing to whatever the user provides. And as long as the user didn't, as long as the website didn't allow the user to have an XSS intersite already, this was almost safe. You still shouldn't do this, but even if you were doing it, it was not so bad. So this was completely safe. However, suddenly we introduced the cross-origin resource sharing thing, which means that now you can do this. You can do another URL that is from a different origin into an XML HTTP request. And that created a lot of problems. A lot of sites were affected, including Google, Yahoo, and Facebook. So yeah, that's another example. So it's not, it didn't happen just once. It happened several times. So this is another example. I'm not going to spend too much on this, but the way that they introduce CSS3 parsing rules and error recovery allows that something that used to be used to be impossible to do, but they introduced this new syntax. And because they introduced the syntax of quoted attributes inside selectors, then now all browsers are affected by people doing this. Another example is HTML parsing. So this used to be safe. Now it's not safe anymore. They interact with each other and with browsers. They get up to date on all the features and changes and bugs found in each browsers. And when they have free time, they can write the code, which is not, that's not a very good way of saying this. The other alternative is to, when we're writing the spec, think of all the different ways that all the features might interact with each other, all different permutations of features, how they differ, how they change. And that's actually what the standard recommends. So, as many people as possible that can think of any use case that they might have, when they see that they implement new things, I think the only way of doing this correctly is to get everyone to, or at least as many people as possible, to see to see all the new features that are implemented and how they might differ with each other. Like the more eyes that are looking at the problem, the more likely it is that we're going to catch the next gotcha. I mean, the 141 and the 142 and etc. It's actually pretty easy because the W3C mailing lists are open for everyone to join, and they move really slow, so there is time to find the problems. Before you use a feature in a very special way, I would recommend you to verify it's an intended use case or a documented use case in the mailing list. It's very hard to find that, but at least you can give it a try. So they aren't evil, the standard wells aren't evil. They add security warnings whenever they find problems, and they have done several times when we ask them. But the standard changes too fast. So there are a lot, while the features are introduced very slowly, there are a lot of features being added at any given point of time. So while you can be kept up to date of all the new features that are done, it's really hard for you to just simply say like, I'm going to read the standard now, and in the next 3 months it's going to be completely different. So yeah, we need people's help to be able to do that. And that's it. That's the presentation. Thank you very much for Ty and Tetcon for understanding you for letting me come here. I'm going to make some ads. We're making a competition a programming competition that is going to be held on Singapore on April, and it's open for only students. So if any one of you want to participate, go to that link or let me know your email and I will let you. And that's it. Thank you very much. Questions? Questions? No questions? Yeah, questions. Okay.
Is there any question for the speaker? Có bất cứ câu hỏi nào cho diễn giả không? Xin mời giơ tay lên. Như vậy thì sẽ tiếp nối sau phần thuyết trình sẽ qua bài nói khác ạ.